In this paper, we propose a weighted multi-scale attention module to apply makeup style transfer on low quality images. So some of the problems with state of the art is they rely on this face parsing algorithm as a hard attention module. So on high quality front facing well lit images, it works very stably, it works perfectly fine, but on lower quality images, it's not so stable. So you can see because the eyes are closed, it has some difficulties segmenting the eyes. It also has some difficulties with occlusion here. And then when we downsample the image to 144p, a lot of noise is introduced into the final result. To counter this, we are going to propose a new makeup style transfer algorithm, which is going to use Augmented CycleGAN as a backbone. Very quickly, the input image is going to have a makeup style ZY applied onto it in the blue arrows. The second step is in the orange arrows, where a D makeup style is going to be inferred from images X and Y hat. This D makeup style is then applied to Y hat to try and recover the initial input image. This is marked by the green arrows. And then finally the red arrows show that we also try to recover the initial makeup style ZY hat. And then these two outputs are going to be governed by a cycle consistency loss to compare them to the initial inputs. So our multi-scale attention module that we propose in this paper is essentially a sequential spatial attention module followed by a channel attention module. So the channels are squeezed in the channel dimension, so you get this H by W representative feature map, and this feature map goes through 3 convolutions at different kernel sizes, very similar to the original Inception network. And these different intermediate attention maps are actually going to represent different things about the image. So the 1x1 convolution will be better at understanding eyeliner, whereas the 5x5 is going to be better at representing fake tan. So these attention maps then get concatenated behind one another, and we perform a channel attention or a squeeze-in excitation operation, which is going to work out which of these channels is most important for the input image. So essentially we have this dynamic spatial attention which is governed by the channel attention. And as with many attention modules, this is going to go through a 1x1 convolution and then gets multiplied by the initial input. Our individual architectures are very similar to the original Augmented CycleGAN implementation, where we add attention modules in the layers that have got large feature maps. And I think the most interesting addition that we've made here is to actually use an attention module directly on the image in the encoder to better understand the makeup style in that image. For quantitative evaluation, this is very difficult to do for makeup style transfer, so we create our own metric and develop our own dataset from YouTube makeup application tutorials. So we use the face parsing algorithm to segment the face, and only once we've done that do we downsample the faces, so we get the ground truth segmentations for the low quality images. Then we compute the L1 distance between different face parts from the real makeup to the fake makeup images, so we can see how well our method did when it came to trying to apply that makeup style. So we perform quantitative evaluation on our model, and we see that we outperform the state-of-the-art DMT and BeautyGAN. In particular, we have a large outperformance on transferring eye makeup, and we believe that this is because of the 1x1 convolution within our attention module. We also perform an ablation study, removing the multi-scale attention and replacing it with a regular attention module, and we also see what happens if we completely remove attention, and we see that our method performs best. Lastly, we provide qualitative evaluation, where the top row contains difficult makeup style images, and we're trying to apply those onto the image in the left column. And you can see quite clearly that ours performs best. We do the best at transferring the skin tone in caption A, and we also manage to best transfer the fake eyelashes in caption B, and we come closest to transferring the really difficult unconventional butterfly wings that are shown as well. So for more results, please do look at our paper, and you can also browse the supplementary materials. Thank you very much.